Hey everybody, in this video we're going to be able to understand and apply the idea of oxidation states to elements and to elements within a compound. Okay, so here are the kind of 7 basic rules of oxidation states. Okay, some are kind of straightforward, that elements have an oxidation state of 0, and that ions, like if you have a calcium 2 plus ion, the oxidation state is the charge, which is a 2 plus, in some of these, okay? So you can pause the video and write all these down, but the easiest thing to do is to do some sample problems. So let's do some sample problems and determine what some of these oxidation states are. Okay, so here is some sample problems straight out of a book, I guess. And so let's keep in mind, okay, so sodium, okay, so I guess the sample problem here is determine, let me give the rules, determine the oxidation state, not the rules, what am I saying, the directions, okay, determine the oxidation state of all the parts and all the elements, and then determine what's being oxidized and reduced. Okay, and so sodium is an element, so it has an oxidation state of 0, and chlorine has an oxidation state of 0. Okay, that's an element as well. Now, sodium in sodium chloride has a charge. Okay, and we're not going to do anything different than what we learned kind of about ionic compounds. Sodium typically has a +1 charge, so that's what it's going to be. Okay, we're not going to learn a whole new set of rules doing oxidation states. We're just going to change kind of that word from oxidation state, or from charge to oxidation state. Okay, and so sodium has a +1 and chlorine has a -1. So now what we can do is we can determine what's being oxidized and what's being reduced. Now, I kind of always pick out the reduced one because reduction is where the charge goes down. So from 0 to -1, this has got to be the reduction. And then sodium, this has got to be oxidation. Okay? Remember, you can't have one without the other. It's like love and marriage. Okay. Right, love and marriage, love and marriage. Dun, 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 dun. I don't know. Okay, so here we go. Let's do this. So iron. So this has an oxidation state of 0, and aluminum here has an oxidation state of 0. But iron in this thing, let's see. Oxygen is always a 2-, right? Oxygen is always a -2, except when it's bonded to fluorines and peroxides and superoxides, which this is not a peroxide or a superoxide or anything. Okay, so 98% of the time, oxygen's oxidation state is going to be 2-. So if this is if oxygen is 2-, there's 3 of them, so that makes 6-. And so that makes 2 of these, so this has got to be 3+. Okay, now we do the same thing over here with this oxygen is always 2-. Notice it is not changing oxidation states. Okay, so 2- times 3 oxygens, so this is a 6-, so this has to be 3+. So again, I always find it easier to do the reduction first. So this is the reduction half reaction, or this is the reduction reaction, and this has to be the oxidation reaction. You can't have one without the other. Okay, so here's kind of a more complex reaction. We have copper reacting with probably nitric acid, NO3 1-, that's the nitrate ion. Okay, and so copper, that has a 0 charge, and here has a 2+ charge. So going from copper to 2+, from copper metal to copper 2+, that's going to be, well, it's not going down in charge, it's going up, so that's going to be an oxidation. Okay, now water is still water here, so that's not being reduced or oxidized. Hydrogen is not being reduced or oxidized. Oxygen isn't being reduced or oxidized in this case. Okay, and oxygen here is a 2-, and oxygen here is still a 2-. So the only other option that we have to see what's being reduced and oxidized has to be, and I'll do it in red because there's a lot of writing, has to be this nitrogen. Okay, so now keep in mind rule 7 from this list. It says the sum of the oxidation states must be the total charge on the substance. Okay, so here oxygen is always going to be 2-. How many of them are there? Not always, almost always. 2-, so that's 6-, but we need a charge, an overall charge of -1. So we need so this is going to be, let's see, 6-. So we need this to be 5+. So 5+ and 6- add up to be 1-. And now here, this is going to be, again, -2. And there's 2 of them, so that's 4. So this has to be 4+. And so this guy is the one that's being reduced. Nitrogen is the one that's being reduced. Okay? So those are some examples on how to determine oxidation states using those rules. And as soon as you get this, then we can move on to doing some more complex redox reactions. Okay, have a great day.